Good morning, everybody. Welcome back to Mr. Muller's fifth hour, eighth grade science class. So, just going to have a short little lecture today. I'm going to talk about what we're going to do. We're going to just read from the book, pages 10 through 13. Then we will be done for the day. So, today we're going to read chapter 1.2, which is Earth in Space, and it's really kind of focusing on the seasons. Okay, so I'm going to start off on page 10, the textbook here. I'm not going to read my planet diary, but I'm going to skip past that. I'm going to start reading page 10 through 13 right now. If you'd like to skip forward on this, you absolutely can. Okay. So again, I'm not reading my planet diary, so actually skip forward to page 11. Apologies. How does Earth move? Until a few hundred years ago, most people thought that Earth stood still and the sun, moon, and stars moved around it. But today, scientists know that Earth itself moves and that objects seem to move across the sky because of Earth's motion. Earth moves in space in two major ways: rotation and revolution. Rotation. The imaginary line that passes through Earth's center and the North and South Pole is Earth's axis. The spinning of Earth on its axis is called rotation. Okay, so put a pin through the North Pole, through the Earth, goes out through the South Pole. That's the Earth's axis, and it spins on it. Okay, that's called rotation. Earth's rotation causes night and day, as you can see down in figure 1. Okay, it looks like the continent of Africa and the Middle East and Europe, you can see is clearly being shined on by the sunlight. Okay, it's daytime there, it's facing the sun. And the side of the Earth that's not facing the sun is going to be nighttime. As Earth rotates eastward, the sun appears to move west across the sky. As Earth continues to turn to the east, the sun appears to set in the west. Sunlight can't reach the side of the Earth facing away from the sun, so it is night there. It takes Earth about 24 hours to rotate once. As you know, each 24-hour cycle of day and night is called a day. All right, we're almost done. Page 12. Revolution. In addition to rotating, Earth travels around the sun. Revolution is the movement of one object around another. One revolution of Earth around the sun is called a year. Earth's path or orbit is a slightly elongated circle or ellipse. Earth's orbit brings the planet closest to the sun in January. Now, funny that that's the truth when that actually doesn't make a difference about, temperatures on Earth. A big misconception is, well, during the summer we're closer to the sun, and during the winter we're farther away. That's actually not true. It is slightly true in the way that the Earth tilts, but in our orbit, we're actually closest to the sun in January. And as you guys know, Minnesota in January is incredibly cold. So closer to the sun, yes, means you heat up, but for the Earth's sake, its orbit being closer to the sun doesn't really make a huge difference. Now, if we were Venus or Mercury, yes, it would be warmer, right? And if you're Mars, Jupiter, Saturn, Uranus, Neptune, those planets are colder because they're farther away from the sun. So yes, closeness to the sun matters, but really in the Earth's orbit, when we get a little bit closer to the sun, it doesn't really change a whole lot of things when it comes to temperature and seasons. That has to do with the tilt towards the sun or away from the sun when it's going on its revolution orbit around the sun. See that wonderful picture, figure 2 on page 12? Okay, page 13. The history of the calendar. The ancient Egyptians created one of the first calendars based on star motions. They calculated the year was about 365 days long. That's pretty good. They divided the year into 12 months of 30 days each with an extra 5 days at the end. Excuse me. The Romans borrowed the Egyptian calendar, but Earth's orbit actually takes about 365 and 1/4 days. The Romans adjusted the Egyptian calendar by adding 1 day every 4 years. You know, this year's fourth year is a leap year, when February is given 29 days instead of 28 days. Using leap year helps ensure that annual events such as the beginning of summer occur on the same date each year. The Roman calendar was off by a little more than 11 minutes a year. Over the centuries, these minutes added up. By the 1500s, the beginning of spring was about 10 days too early. To straighten things out, Pope Gregory the 13th dropped 10 days from the year 1582. He also made some other minor changes to the Roman system to form the calendar that we use today, or the Gregorian calendar. Okay? Assess your understanding at the bottom. What are the two major motions of Earth as it travels through the space? That's rotation and revolution. Which motion causes day and night? That's the rotation of Earth on its axis. Why do people use Earth's motion to determine units of time? Well, Earth's motions are regular. Okay, they're consistent, so people can use them to measure time consistently. Okay. So there's the reading for today. Let's go over the notes real quick. So based on the reading, you will not have a Google form question today, but you will have to make a Flipgrid. And that Flipgrid is already up on Google Classroom. You've probably already looked at that. But that is, you're going to have to use yourself, somebody else, or objects to describe the difference of motion between rotation and revolution and create a little Flipgrid for that. Then you're going to have to watch an Edpuzzle, which I will link with this video on Google Classroom. Okay, let's get through these notes here. I can describe why Earth has seasons. That's kind of the main learning target for this. Earth moves in two major ways, like I said during the reading, rotation and revolution. The imaginary line that passes through the Earth's center and the north and south poles is called its axis. Earth's rotation causes day and night. Then Earth turns from west to east. Okay, so imagine you're in my classroom. It turns from the parking lot, the main parking lot, to the east, which is the track and football stadium, which makes it look like the sun is traveling from east to west. That's why it rises in the east and sets in the west. Makes sense, right? How long does it take for Earth to rotate once? It takes 24 hours for the Earth to rotate one full time on its axis. What is a revolution? It's the movement of one object around another object. Revolving around something, right? What is an orbit? The path of a planet or space object when it revolves something like the sun. So the Earth's orbit is revolving, it's around the sun. What is the shape of Earth's orbit? It's not perfectly circular. It's what we call elliptical or slightly elongated, kind of like the shape of an egg. An egg is not, you've probably seen some eggs that are kind of weirdly shaped, like perfect little circles, that look like maybe like a golf ball. That happens occasionally, but like 99% of eggs are this elliptical elongated shape, which is what an orbit is as well. How long does it take for Earth to orbit the sun? About 365 and 1/4 days to orbit the sun. So then the important part is what causes the seasons? Earth has seasons because its axis is not straight up and down. It's actually tilted as it revolves around the sun. This tilting results in the temperature differences because different latitudes or places on Earth, like at the top, middle, or bottom of the Earth, receive different amounts of sunlight. So when the Earth is tilted, where the northern hemisphere, where we are, okay, America, Canada, stuff like that, is facing towards the sun, that's going to be our summer months. Where the southern hemisphere, like Australia, stuff like that, that's going to be their winter months. And then the reverse is true when we're tilted away, okay? And of course, the axis is tilted 23.5 degrees on its axis. When it is summer in the northern hemisphere, what is happening in the southern hemisphere? It's the very exact opposite. It is winter. Talk a little bit about solstices. Okay, solstice occurs when the sun is closest north or when the sun is closest south. Okay, that is a solstice. We have two of those every year. What are the dates of the solstice? In the northern hemisphere, June 21st is the summer solstice. Makes sense. That's the middle of summer. And then it's the longest day of the year. Okay, around the time where we get our hottest temperatures as well. And December 21st is the winter solstice. It is the shortest day of the year. You've definitely experienced that when we get to December. The sun doesn't rise till, I don't know, like 8:30, maybe 7:30, somewhere around there. And then it sets really early, like 4:30 or 5 or something like that. But in June 21st, it rises at 5 and it sets at like 9. It's beautiful. What is an equinox? An equinox occurs when neither hemisphere is tilted towards the sun. So, you have the solstice where it's tilted the most towards the sun or most away from the sun, and then equinox is kind of where it's right in the middle. Neither hemisphere is tilted more towards the sun. On an equinox, day and night is about 12 hours long everywhere. Okay? What are the dates of the equinoxes? March 21st. So we just had our spring equinox, and then September 22nd is our autumnal or fall equinox. So I want you guys to recognize that gravitational force exists between any two objects and describe how the masses of the objects and distance between them affect force. Okay? I believe I am going to stop there. I went a little ahead with the notes here, but that's okay. So the next part you're going to be reading up about seasons. So I described it here. Hopefully that helps. And then we're going to read about gravity and force and things like that. Make sure you watch the Ed puzzle that will be attached to this Google Classroom assignment with this video. And then make sure you complete your Flipgrid. It's about a 1.5 minute long video describing the difference between rotation and revolution. Have a wonderful day, guys. Thanks for listening. Bye.